All right, what I have up here is instrument approach chart, and they're published for all aerodromes everywhere, provided they have some allowance for an instrument approach. There are two basic instrument approaches to aerodromes or airports, and one, it's non-precision or precision. Now, precision approach is where you have the radio navigation instrument landing system, or ILS, which is very accurate, and it can bring you right down to the end of the runway without having to, like, fully automatically. It controls the, or it tells you whether you're too high, too low, or too much to the left, too much to the right. A non-precision approach is either the old-fashioned way of coming in on a non-directional beacon, which is just a normal radio beacon, like a marine beacon, only at the airport, or the VOR radio navigation, which will get you into the proximity of the airport, and that works by like spokes on a wheel. The radio navigation doesn't just tell you what direction the station's at, it tells you what degree or angle you are from it. So it can allow you to follow a fixed radial in or away from the radio station. Say you can tune it into 270 degrees, and it'll tell you whether you're going off to the left or right of it, whether you're flying towards or away from the station. All of those non-precision approaches demand that you have to break out of the clouds at a sufficiently high altitude that you can now visually land the airplane at the runway. Whereas a precision approach, it's more or less the same, but it allows you to go way closer to the ground before you break out of the clouds. So on this approach plate here for Victoria, there's Victoria Airport, only for landing on runway 09. Right at the bottom here it shows if you're landing on the ILS system, you can be 305 feet above sea level, indicated. If you're coming in on one of the non-precision approaches, then it's going to be much higher than that. For a localizer DME, which is the same as an ILS, except it doesn't really tell you your height. You have to figure that out yourself using the altimeter. So you have to break out of the cloud a little higher. A circling approach, where you're actually visually breaking out and looking for the airport, you have to be even higher still. 600, it all depends on the other variables. Now on the approach, there are different waypoints that are usually identified by the modern GPS. So at runway 09, you have this waypoint. You have to be at 4,000 feet to be there because of the hills. Once you get to this waypoint, you can start descending down. You're at 3,600 feet. You can descend down towards 2,300 by the time you reach this one. At 1,400 feet, you're at the Mill Bay non-directional beacon, which is right in line with the runway in this particular case, across the bay on the land from the threshold of runway 09. And then from there, you're down to a landing. So a precision instrument approach will take you down this without you having to calculate and determine and make the airplane go to those certain altitudes. The instrument approach system, if you follow it, will automatically take you down that glide path. The one example, using the older style instruments, you manually fly the airplane following the needles to tell you whether you're left, right, or up and down. On modern systems, it's connected with the autopilot, which will make the plane do it automatically. So, straight up and down view, Victoria Airport, Mill Bay non-directional beacon, and all the corresponding waypoints that are on this chart. It gives the frequency for the non-directional beacon, which we'll have the plane tuned into. Up here it gives the frequency for the instrument landing system, 108.7, and all the other information, including a look at the terrain. Now this line, if you make a missed approach, for whatever reason you don't break out of the cloud, or you don't see the airport when you do, or the clouds are lower than the limits allow, you do a missed approach and you continue climbing up, following this track, and eventually aiming for the non-directional beacon at active pass, which is also used for marine use. And there's the frequency and the Morse code identifier. So that's how the basics of an instrument approach chart. This, of course, you understand very well before you even try to make a landing at the airport. So with that in mind, let's give it a try. All right, we're in a Cessna 172. Now we have modern navigational equipment on board, as you can see. The glass cockpit. This is a Garmin 1000, which is the latest, and it's highly integrated. It does pretty much everything that the pilot used to do for changing frequencies and switching from a GPS approach to an ILS approach. What we're using the 172 for is to show how once GPS was approved for navigational landing and for landing an aircraft, we'll show how it integrates with the old-fashioned precision instrument approach procedure. Now on the indicator here in purple means that the navigation is set for GPS approach, which is primarily, we call it RNAV. It's one form of RNAV where you're using radio navigation to approach. GPS, of course, is much more versatile because it'll take you right to a certain waypoint. We're not using non-directional beacons and an ADF to detect them or VORs. The GPS takes you right there. Now, when it shifts to green, the navigational equipment automatically changes it over to the radio precision instrument approach, or ILS, which is what we've used for years. And that's still more precise than a GPS to bring you right down to the threshold of the runway. So where we are now is we are cruising west of the Victoria Airport. That's us, following the purple line. And we are going to line up with this GPS waypoint, make a 180-degree turn, and line up and shift over to the instrument approach and do an approach on runway 09. So this shows the more modern way to do it when you have GPS. You don't need a Garmin 1000 to do this. You can do it all manually. But with the flight simulator, this is all I've got to use. So we'll start it going. We are essentially not really backtracking, but we're heading in the wrong direction. And once we pick up this waypoint, and let's say we're directed by the air traffic controller, which in this video you don't hear him at all, but the air traffic controller is telling us and approving everything we're doing, because the general thing in instrument flying is you haven't got a clue what's out there. So air traffic control tells you what to do and how to get there. You have some say in the matter, but it's so much easier than visual flight rules, which is like looking out the window, because they tell you where to go and what to do, and all you have to do is do it. And it's the doing that is a little harder than flying a plane normally when you can look out the windshield. So away we go. Let's get it started. So we are heading to the waypoint VIXAS. So you can see outside we couldn't possibly see any traffic coming. I can't really tell where I am, so we're using all the air traffic control and instruments. So I'm going to bring this map up. Let's say that's on our knee there, or let's say it's a GPS. It's the same as the map over here, but we can move it around a bit easier. There's the airport. There's the non-directional beacon at Mill Bay. There's another GPS waypoint and the one we're aiming to. So when we get there, we want to, according to the approach chart, we have to be at 4,000 feet. If you look at the setting here, we are flying at 4,100 feet at proper cruise, and so everything's looking pretty good. Now, things are really smooth because I'm on autopilot. Now, autopilot can do a much better job at keeping on track and flying glide slopes than I can. So that's what autopilot's for. And if you get disoriented, flicking on the autopilot gives you a bit of a break, because as I'll show in another video, the biology of flying on instruments is that your balance organs can trick your brain into thinking you're doing one thing when the instruments prove that you're not. So you have to, it takes tremendous practice to learn to follow the instruments and ignore what your balance organs and brain are trying to tell you that is happening, because it's false. So 4,100 feet, we're on GPS, on autopilot, the altimeter's set, so the plane's flying itself here. We have the navigational radios and communication radio frequency set at 108.7 for the ILS. So we're coming up to our turn, and we're doing a rate 1 turn, 2-minute turn, which is pretty standard, like about a 20-degree bank. So we're doing almost a 180, so it should take about a minute to get around. Maintaining altitude. Once we get on track, then we'll start our descent, because at Vixus we can be dropping down to 3,600 feet. By the time we get to Medba, we should be at 2,300 feet. So I've reset the altitude, and we'll start the plane in descent. Now, once the plane is flying based on GPS mode tracking, direction and altitude, then now the throttle can be used to vary the speed of the aircraft, because the navigational equipment automatically maintains the vertical speed, and so the throttle, instead of when you're flying manually, varies the vertical speed. Now the throttle just works the airspeed, because the computer is doing whatever it takes to keep that vertical speed constant. You can also, by pushing another button, have it the other way around, where you can maintain your airspeed, and by pulling throttle, change your descent rate. So it's up to the pilot's discretion. So right now I've chosen to maintain the airspeed, and by using throttle I can speed up or slow down the descent rate. And I want to try and time it, so by the time I get to the next waypoint I'm at the correct altitude. So I'm descending at about, that looks like 450, maybe pushing 850 feet per minute. So this system does a much smoother job at flying the plane, because all a pilot has to do is put in the numbers that he wants, and the plane will do it. Now, just out of, if you're at all interested, this Garmin 1000, if you were going to install it into your plane, which you can't do, it's going to cost you $55,000 US. It's expensive. So look what just happened. It changed over to green, which means we're now on the localizer on the glide slope. That GS indicates glide slope, AP, autopilot, and localizer, LOC, means that we are locked in. So now the plane is using the old-fashioned radio navigation, high precision instrument approach, the ILS. We didn't have to manually change it over. So now what's improved is that the plane will now automatically take care of altitude. So it'll fly left and right centered and up and down centered. All we now have to do with the throttle is make the plane speed up and slow down. So you see how things have changed. Now the throttle changes the speed of the aircraft. And the ILS, automated system, will make sure the plane follows at the exact correct descent rate. So that's the big difference between going from purple to green. We've gone from GPS system to ILS system. So now we're essentially following like a big string all the way down to the runway numbers. and all we have to do is work the throttle to make sure the airspeed is correct. So right about now we can put on 20 degrees flaps for normal landing, although it's a little early. We'll wait till we get past the Mill Bay beacon, which is coming up, as you can see on the chart. So airport altitude is just over, like it's only about 100 or 200 feet. We're at 1700, so we got a ways to go. Now, in another video I showed me flying this manually in a Cessna 150. Well, as you can see, the automated system does a much more precise job than a human can do. So my job is just to monitor the numbers. Now the weather minimums for Victoria Airport on an ILS system is 305 feet above sea level, which is about 250 feet above ground, or thereabouts. So if we don't break out of the cloud by then, we have to do a missed approach and fly up and decide to go somewhere else. So here we're past Mill Bay. Let's put our 20 degrees flaps down. Now when we're on the ILS locked in, the speed will just drop. The attitude of the plane won't change, which is not usually what happens, but the only response is the speed slows down. But that's okay. We'll keep the throttle the same and let the airspeed drop down from 90 down to into the 80s and eventually down into the 70s. So we're halfway across the bay, and I can just start to see straight ahead of us the strobes at the end of runway 09. So pretty soon we'll be visual. However, because we're on the ILS and it's doing a better job than I could, we'll continue to keep the autopilot on and fly the ILS closer to the ground rather than change over to visual. So we're still landing on instruments even though I can see where I'm going. So we'll bring it down to where we're almost over the threshold, and then I'll kick out the autopilot, take over manual control of the aircraft, and do a normal landing. So keep an eye on the VASI lights. The VASIs are the red and white lights that indicate whether we're above or below the glide slope, and you can barely see it on the left there, just away from the strobes. You can see one red and one white. It'll be a bit more clear when we get closer. So that indicates we're right on the glide slope. The ILS, also that little vertical green bug, shows that we're dead on. So everything's perfect. So I'm throttling back into the 70 knot range. As you can see there, 20 degrees of flaps, coming up to a normal landing. And pretty soon I'll kick out the autopilot. You'll see the green AP there disappear. And we now have we'll have manual control of the aircraft. There it goes. I've kicked it off. Now I'm flying the plane. And already you can see I'm flipping around a little bit here. Not quite as good as the computer. And down we go. Okay, lose the flaps and full braking, and that gives you a bit of an idea of the modern simple approach intercepting an ILS and landing in instrument conditions.